David Hilbert, a name synonymous with mathematical genius, was a towering figure in the world of mathematics. His intellect and vision left an indelible mark on the field, influencing generations of mathematicians. Hilbert's contributions to mathematics are vast and profound, spanning numerous areas such as algebra, number theory, and mathematical logic. His work laid the groundwork for many modern mathematical theories and practices. Born in Königsberg, Prussia, now Kaliningrad, Russia, in 1862, Hilbert showed an early aptitude for mathematics. His hometown, a hub of intellectual activity, provided a fertile ground for his burgeoning talent. Hilbert's contributions to mathematics are vast and profound. He developed the theory of Hilbert spaces, which became a cornerstone of functional analysis. His work on invariant theory and the foundations of geometry revolutionized these fields. His work transcended traditional boundaries, shaping the landscape of 20th century mathematics and beyond. Hilbert's influence can be seen in the development of quantum mechanics, general relativity, and computer science. This essay delves into the life, work, and enduring legacy of this mathematical titan. Hilbert's approach to mathematics was characterized by his clarity of thought and his ability to see the underlying structure of complex problems. Hilbert's influence extended far beyond his own research. He was a mentor to many prominent mathematicians, including Emmy Noether and John von Neumann, who themselves made significant contributions to the field. He possessed an unparalleled ability to identify fundamental problems, often posing questions that would guide research for decades. His intuition and insight were legendary, allowing him to navigate the complexities of mathematics with ease. His intuition guiding him to the heart of mathematical complexities. Hilbert's ability to distill complex ideas into fundamental principles made his work accessible and influential. His famous list of 23 unsolved problems, presented in 1900, set the stage for a century of mathematical exploration. These problems challenged mathematicians to push the boundaries of their knowledge and explore new frontiers. Set the stage for a century of mathematical exploration. Hilbert's problems have inspired countless mathematicians, leading to significant breakthroughs and advancements in various fields of mathematics. David Hilbert's journey began in Königsberg, a city steeped in intellectual history. Königsberg, known for its rich cultural and academic heritage, provided a fertile ground for young minds to flourish. The city's vibrant academic atmosphere was a perfect backdrop for Hilbert's early years. Growing up in a family that valued education, Hilbert's passion for mathematics ignited early. His parents, recognizing his potential, encouraged his curiosity and love for learning. Surrounded by books and scholarly discussions, Hilbert's home environment was a catalyst for his intellectual growth. His exceptional abilities were evident from a young age, setting him on a path to greatness. Teachers and peers alike were amazed by his quick grasp of complex concepts and his innovative approach to problem solving. Hilbert's early academic achievements hinted at the remarkable contributions he would make in the future. Hilbert pursued his higher education at the University of Königsberg, where he immersed himself in the world of mathematics. The university, renowned for its rigorous academic standards, provided Hilbert with the perfect environment to hone his skills. Here, he was mentored by some of the leading mathematicians of the time, further fueling his passion for the subject. He earned his doctorate in 1885, his dissertation marking the beginning of a prolific career. His doctoral work was not just a formality, but a significant contribution to the field, showcasing his deep understanding and innovative thinking. This achievement opened doors to numerous opportunities and collaborations. His work quickly gained recognition, establishing him as a rising star in the mathematical community. Hilbert's early publications and lectures were met with great acclaim, and he soon became a sought-after figure in academic circles. His ability to tackle complex problems with clarity and precision set him apart from his contemporaries, paving the way for a legacy that would influence generations of mathematicians to come. At the 1900 International Congress of Mathematicians in Paris, Hilbert delivered a lecture that would reverberate through the halls of mathematics for generations to come. He presented a list of 23 unsolved problems, carefully chosen to represent the most significant challenges facing mathematicians at the dawn of the 20th century. These problems, ranging from the foundations of mathematics to number theory and beyond, ignited the imaginations of mathematicians worldwide. Hilbert's 23 problems became a call to arms, inspiring countless mathematicians to dedicate their lives to unraveling these profound mysteries. One of Hilbert's most significant contributions was his work on the axiomatization of geometry. Euclid's Elements, the cornerstone of geometry for centuries, had certain logical shortcomings that mathematicians had long grappled with. Hilbert sought to address these issues, placing geometry on a more rigorous foundation. Hilbert's approach involved identifying a set of fundamental assumptions, or axioms, from which all other geometric theorems could be logically derived. His axiomatic system, published in his groundbreaking book Grundlagen der Geometrie, or Foundations of Geometry, in 1899, revolutionized the way mathematicians approach geometry. Section 5. Invariant Theory and Algebraic Number Theory, Expanding Mathematical Horizons. This section delves into the profound contributions of David Hilbert, a towering figure in the world of mathematics. Hilbert's mathematical prowess extended far beyond geometry. He was a polymath whose work spanned various branches of mathematics, leaving an indelible mark on each. He made substantial contributions to invariant theory, a field concerned with identifying properties of mathematical objects that remain unchanged under certain transformations. Invariant theory is crucial because it helps mathematicians understand the fundamental nature of mathematical structures, regardless of how they are manipulated or transformed. His work on invariant theory laid the groundwork for later developments in algebraic geometry. Algebraic geometry, which studies solutions to algebraic equations and their geometric properties, owes much to Hilbert's pioneering efforts. His insights provided a new lens through which mathematicians could explore the intricate relationship between algebra and geometry. In algebraic number theory, Hilbert delved into the intricacies of algebraic numbers, extending the work of mathematicians like Kummer and Dedekind. Algebraic number theory is a branch of number theory that uses the techniques of abstract algebra to study the properties of numbers. Hilbert's work in this area was groundbreaking, as he explored the deep connections between numbers and algebraic structures. His contributions to this field, particularly his proof of the Hilbert basis theorem, had a profound impact on the development of abstract algebra. The Hilbert basis theorem, which states that every ideal in a polynomial ring over a Noetherian ring is finitely generated, revolutionized the way mathematicians approached algebraic structures. Hilbert's theorem provided a solid foundation for future research and opened up new avenues for exploration in abstract algebra, influencing countless mathematicians and shaping the course of modern mathematics. Section 6. Hilbert Spaces and Quantum Mechanics, a Bridge Between Disciplines. Hilbert's work transcended the traditional boundaries of mathematics, influencing other scientific disciplines. His development of Hilbert spaces, infinite-dimensional vector spaces equipped with an inner product, proved to be instrumental in the development of quantum mechanics. Quantum mechanics, a revolutionary theory that emerged in the early 20th century, sought to describe the behavior of matter and energy at the atomic and subatomic levels. Hilbert spaces provided the mathematical framework for formulating the theory's fundamental concepts, such as wave functions and quantum states. Section 7. Personal Life and Legacy, Anecdotes and Enduring Impact. Beyond his mathematical achievements, David Hilbert was known for his warm personality and infectious enthusiasm. He was an inspiring teacher and mentor, fostering a vibrant mathematical community in Göttingen. His students, many of whom went on to make significant contributions to mathematics, benefited greatly from his guidance. Hilbert's legacy extends far beyond his own research. His ability to identify fundamental problems, his unwavering belief in the power of human reason, and his infectious enthusiasm for mathematics continue to inspire generations of mathematicians. Section 8. Hilbert's Influence, a Legacy of Inspiration. Hilbert's impact on the development of 20th century mathematics is immeasurable. His 23 problems served as a roadmap for mathematical exploration, guiding mathematicians towards some of the most profound discoveries of the century. His emphasis on rigor and axiomatization transformed the way mathematicians approach their craft. His work on Hilbert spaces laid the groundwork for the development of quantum mechanics, demonstrating the profound interconnectedness of mathematics and physics. Hilbert's legacy lives on in the countless mathematicians who continue to be inspired by his work. Section 9. Conclusion: The enduring brilliance of David Hilbert. David Hilbert's contributions to mathematics are etched in the annals of history. His ability to identify fundamental problems, His rigorous axiomatic approach and his far-reaching influence on other disciplines solidify his place as one of the most brilliant mathematicians of all time. His work continues to shape the landscape of modern mathematics, inspiring generations of mathematicians to push the boundaries of human understanding.